Thomas.
Are you okay?
Either I'm too small or Thomas is too tall.
Okay.
One of the options. Ladies and gentlemen, dzień dobry. I am delighted to be here. My name is Justin Abbott, and I'm honoured to be able to present at this conference. And I really hope that you have an energising couple of days. The title of the talk is Integrated Water Management, Next Generation Infrastructure. And I think the key themes I'm trying to reinforce are the need for increased integration across the urban water cycle, as we've already heard about this morning, including stormwater, and the ability to deliver next generation infrastructure solutions as defined by the World Bank, using new techniques such as nature-based solutions and new processes, including digital processes. And in terms of context, I think this is a huge opportunity for all of us in this room. There are clearly urban water and stormwater challenges that we need to address in a changing climate, but there is also an opportunity to rediscover the positive role of water and to reconnect the city and its inhabitants with water and to deliver a successful, resilient, healthy and sustainable city. And I'd like to set the context in terms of some broader agendas. I have a water hero. I don't know if you have water heroes. My water hero is John Snow. John Snow, in the mid-19th century in the UK, made the link between cholera and water standpipes in London. And on the back of the insight he delivered, we transformed how we built cities in the UK and around the world. And I think as a community here, working with others, we also have the ability to transform the relationship between the city, water, and health and well-being in the 21st century. The challenge is there. Where are the impacts of climate change upon our urban environment? And I frequently refer to the World Economic Forum global risks to emphasize this. Looking forward over the next 10 years, globally we see some key risks coming to fruition, whether that's failure to mitigate climate change, failure to adapt to climate change, extreme weather events, or our natural resources becoming increasingly stressed. Water is at the heart of all of that. And whilst our focus here may be on water, clearly we cannot deliver by focusing on water systems alone. Water and biodiversity are inherently interlinked, whether that is through the impacts of water on ecosystems, the core needs of water to sustain our ecosystems and allow them to function, or increasingly the ability of these natural systems, such as nature-based solutions, to support innovative approaches to managing water. And I've already made reference to health. But if, as a society, we are to deliver on the wider One Health agenda, we have to understand and manage water, whether that's returning to natural flows within our cities to support environmental health, or managing CSOs to improve water quality and public health. So the opportunity, I think, is there for all of us, for a next generation of infrastructure, including one that can harness the power of nature and deliver wider value. And in Arup, we have tried to frame that opportunity through our design with water approach. The approach is summed up in this diagram, a whole systems framework, one that rethinks our water assets as an integrated system that needs to be understood and managed as a system rather than discrete systems. One that rethinks the stewardship of those assets, thinking about assets that are resilient, smart, integrated, and regenerative. And one that rethinks value, which I think is really important, recognizing the wider role water plays within our cities and our communities. And shifting the viewpoint of our integrated water system from one that prioritizes the water system and constrains other assets, as I think we have done in the past, moving towards a regenerative system where water assets restore and enhance other systems, actively enabling wider outcomes. And to do that, to move from vision through to delivery, we need to be able to do a number of things. We need to be able to work across systems, including biodiversity and communities. We need to be able to work at detail, but also at scale. And increasingly, I think, we need to be able to work at scale to allow us to plan and strategize for integrated approaches. And new digital technologies will be key to us being able to do that, to deliver broader and faster insight. And we need to address governance and funding issues, exploring collaborative delivery and new business models that could support wider and more rapid adoption of blue-green approaches. So to help maybe more clearly describe some of the thinking, I've identified a number of areas of ongoing work and research within Arup. I'm very much providing an overview of these, and where available, I've provided links to allow you to explore in more detail if that is of interest to you. So the first exploration is our campaign around sponge cities. I don't know if you've seen that in the press, but cities are key stakeholders in adapting their water systems to increasing threats from climate change. They need to fully understand how nature-based solutions and green infrastructure can help mitigate these effects. And we published a report recently with the World Economic Forum highlighting the cost effectiveness of nature-based solutions and the potential they bring to provide added benefits. A number of cities around the world are addressing the challenge, but we need to accelerate. The aim of our Sponge City snapshot was to get people and cities talking about how we can move beyond concrete-driven solutions for urban water management. And the Sponge City concept was originally developed in China in 2013 and describes the ability of a city to work with nature to manage water more effectively. And we saw an opportunity to raise the profile of this concept with cities around the world using our terrain tool, which we developed whilst working on the Shanghai Water Master Plan. And terrain is an AI machine learning tool, which harnesses the power of data analytics, machine learning, and automation, and is able to digest large quantities of satellite information. It recognizes patterns and is capable of producing detailed land use maps, enabling the city's land cover to be understood at scale, including trees, grass, hard paved areas and buildings. And we use this analysis to explore the amount of blue-green areas across 150 square kilometre snapshots of a number of cities across the world. We look to assess the natural ability of the city to absorb water based on the current distribution of blue and green spaces. I'm showing 8 cities here, but I think we're now close to 20 cities we've analysed across the world. And all these cities, like many cities in Poland, have had recent experience of extreme events, as shown in this image. We assessed each city's sponginess by calculating how much land is impervious or pervious, and then factoring in individual soil characteristics. The outcome of the analysis is shown here, and shows the sponginess index, a measure of the city's natural absorbency. This is not intended to be a detailed analysis of the city's capability to absorb water. It is intended, as noted previously, to raise awareness of alternative methods of managing water. And as a campaign, it was very successful, with huge interest with the cities and the media. And I think there is something here about the right language capturing interest and understanding. The hope was, and is, that the snapshot will start a conversation. What are the characteristics of my city? What more could we do? And this has happened with a number of cities we have looked at, who are wanting to understand more detailed analysis on how nature-based solutions can be deployed to bring more cleaner, resilient, healthy cities. Our message is simple. We want cities to be asking, how spongy am I? My next project is the Mansfield Blue-Green Strategy. This is a project where the use of digital technologies has been key to both securing significant funding, but then also delivering blue-green infrastructure at scale. So Mansfield is a city of 120,000 people, and managed by one of the UK's largest water companies. In 2021, the water utility approached Arup to help them apply for COVID recovery funding being offered by the UK government. The challenge was they needed urgent help to develop a robust business case to secure that funding. We had to very quickly develop a blue-green master plan study for the whole town, drawing on our stormwater expertise to assess and quantify different blue, green and grey scenarios to reduce flooding across the town, quantifying the likely costs and also the multiple benefits. The water utility submitted our study as part of their business case and was successful. They were awarded £75 million to invest to a very tight construction deadline. We were given 1 month to undertake this high-level study, so it was not possible to undertake a detailed investigation supported by extensive hydraulic modelling. Instead, we used an alternative data-driven approach to undertake our analysis. Similar to the work we did on Shanghai, we initially reviewed the study area and identified typical typologies, 14 in total. And you can see that the land uses we settled on, they vary from industry and commercial to different types of residential properties, schools and urban parks. We then used satellite data and Arup's terrain tool to assess the land uses in the study area. The area of specific interest was the town of the Mansfield boundary, which is shown in red here. The output of the terrain analysis was a view across the city of the location and relative proportion of land use types, including spatial layout and areas. The next step was then to map the relevant blue-green measures to specific Mansfield land uses. This gave us an understanding of the measures that are easily deployable in each typology. For example, in this case, permeable paving is deployable in residential areas, car parks, or commercial areas, but not appropriate for other land uses. This matrix was co-developed by the water utility client to match their appetite and level of ambition for green interventions. We then selected typical sample locations for each typology. And for each sample location, we designed solutions for each area using the matrix, taking into account local conditions such as road arrangements, ground slope, traffic, existing infrastructure. The aim of that process was to ensure that there was a robust engineering evidence base behind our proposals to allow us to strongly ground truth the outputs from the digital analysis. So using our digital tools, we were able to establish the potential for each typology, provide blue and green infrastructure and storage. And by combining this data with the land use areas derived by terrain, we were able to quickly assess the potential of the whole town to accommodate blue and green measures and also quantify the number of each intervention. And as part of this study, we used the wider benefits associated with blue and green assets. The benefit mapping exercise uses an input-output outcomes model that displays connections between resources, activities, and outcomes of a project. And for the purpose of this exercise, we also mapped the benefits to a six capitals framework, which is the framework the utilities in the UK generally use for looking at benefits, including natural capital, social capital, financial capital, manufactured capital, and intellectual capital. We were then able to assess and monetize some of the benefits. Benefits were excluded from valuation if information available was not sufficient for a quantitative assessment. Benefit transfer was the main method of monetization used in this study. And the table outlines the value selected for the monetization of each benefit and the formula used for the calculation. And the graph on the right presents the cumulative benefits over 25 years. So how did these wider benefit calculations support the business case? These two graphs summarize the cumulative costs and benefits and the net costs for all scenarios. The monetary values represent whole life costs over a 25-year period. The graph to the left highlights that several scenarios could provide significant wider benefits compared to the traditional solution at lower or marginally higher whole life cost. Blue-green interventions also offer other benefits that were not quantifiable at this stage of the project, so the cost-benefit scenarios could probably be improved. So after securing funding, the next challenge was then to support our client in delivering a rapid rollout program. we recognised that a similar innovative strategy was needed to enable the client to plan the delivery of the project and saw an opportunity for digital methods to be able to help. Whilst the client had a town-wide storage target and a budget and some basic intervention requirements, this was based on a master plan study, aggregated across the town. It did not give sufficient detail to base more detailed strategic decisions upon. We therefore worked with the client to develop a town-wide design tool to assess and locate blue-green infrastructure rapidly on a street-by-street basis, enabling Severn Trent, our client, to rapidly trial different strategies before finalising the overall strategy for the project. And to further support the client in delivery, we also developed a town-wide dashboard that the client is actively using both to test strategies and to monitor delivery. The dashboard has supported them in their decision-making, allowing them to reach a balance of interventions at a cost that they can afford, optimising the process. What they have now is a process that any town or city could replicate that can enable rapid identification of blue-green potential to support both business cases and implementation. The third example, if we are to deliver next generation blue-green infrastructure at scale, we need better tools to understand and identify the potential for the early use in the project assessment process. Too often, nature-based solutions are seen as an add-on or an afterthought. We've been working with Scalgo in the UK to develop a proportionate and accessible tool to enable early exploration of nature-based solutions within catchments. It is not a detailed design tool, but a process that allows impact and benefit to be rapidly considered at an early stage. This then allows potential costs and benefits to be understood and supports early collaboration with stakeholders and landowners to deliver nature-based solutions. The tool is a web-based mapping tool for the initial assessment for the potential of nature-based solutions, initially on flood schemes, focusing on natural flood management. The aim is to mainstream these assessments within scheme design, with the hope that it will lead to greater uptake of these solutions in projects. At the moment, the scope of the tool is limited to the UK. Within the tool, there's a multi-criteria analysis using a range of online data sets that determine suitability scores for 10 types of nature-based solutions, 150-metre grid. Nature-based solution types include attenuation, wetlands, tree planting, for example. The tool is a dynamic interactive tool. Threshold and suitability scores can be set to increase or reduce the amount of opportunities being displayed, and alternative options for nature-based solutions can be sought by changing the suitability ranking. And in addition to considering flooding, the map display can be altered to show the relative suitability for carbon sequestration, for example, or habitat creation. If you select a watershed, you can explore some baseline data, such as baseline carbon sequestration values. You can then look at the potential impacts once nature-based solutions are applied. It is then possible to look at specific interventions. How much are they likely to cost to implement? What benefits could they bring to either carbon or ecosystem function or water storage? And the aggregate tools are dynamically linked, so when you change one criteria, all the outputs, such as cost and carbon sequestration values, change immediately. And you can generate a cost-benefit graph to explore available budget compared with benefits across the scheme, so making sure we can look at good value for money. Whilst remaining in the web-based software, the hydrology of the catchment and watershed can also be explored. This then allows an initial assessment of the potential impacts to downstream peak flows resulting from the mapped nature-based solutions, which can then inform scheme design approaches in terms of the potential for nature-based solutions or natural flood management to support flood risk. We're now actually using this approach across the UK in terms of our flood risk management projects, allowing early identification of interventions to support detailed design and landowner consultation activities. The fourth example is New York, and I love New York as a blue-green infrastructure example. I think it's a visionary program they've operated out there. And I wanted to briefly reflect on our experience in New York which I do see as one of the beacon cities for a blue-green approach, where there is now over 10 years of experience in retrofitting blue-green infrastructure into complex and cluttered urban environments. When we talk to cities and they say it's too difficult, I always point them towards New York. And the New York approach was driven not really by flooding, but by a need to improve water quality in the Hudson, and hence a need to better control CSO spills. A detailed study, as presented in the New York Green Infrastructure Plan in 2010, identified the opportunity for a blue, green, grey solution to manage stormwater, whilst also delivering a cost-effective solution with wider benefits to the city. It was a visionary approach at the time. And Arup has been involved with the project from the early stages of delivery and have delivered almost 1,000 interventions across the city. And over that 10 years, our experience has shown that digital solutions have a key role to play in a large city, whether that's GIS mapping, whether that's mobile data collection, whether that's automated design. But if we are to deliver blue-green infrastructure at scale, we need digital solutions to support us. So the output is a network of interventions across the city. Arup and others have supported in delivery. The outcome is a more resilient city and a far more attractive and healthier city with the potential for wider benefits. And the city is now very experienced in the delivery and management of these systems. And in particular, they have developed processes for the operation and maintenance of these features, which are now an integral part of the city's infrastructure and asset base. And I love this photo. They are now just a key feature of New York's landscape, bringing value to the city beyond their core function. Fifth example is stormwater in London. The argument for blue-green infrastructure has, I think, largely been made. I think we all in this room would support that. And there is agreement in the value that nature-based solutions can bring to urban water management. Often the key challenges are not technical, but financial. We often see challenges around who benefits and who pays. Different collaborative arrangements and market mechanisms are developing to overcome these barriers. The concept of stormwater markets are not new. They have been in place in the US for a while. But in London, we're currently supporting the city in the scoping of a potential market approach there. Like most cities, London has experienced of being badly impacted by extreme weather events, with a big event in 2021 that disrupted a number of properties. The events of the 21st July were a catalyst for change and brought together various parties across the city to explore a new approach to managing stormwater, aligning priorities, working together, sharing knowledge, and looking at co-funding opportunities. And the city is working to strengthen the mechanisms for reducing flood risk across three streams: spatial planning, implementation of SUDs on new assets, and making better use of the public realm. And the aspiration for the city is high through to 2050. But if this ambitious target is to be delivered, the city will need to optimise the opportunities to deliver SUDs across all aspects of the management of the city. One area of particular focus is street works. There are over 20,000 major street works and 140,000 standard street works in London each year, where the city is dug up for maintenance activity, whether that's ICT or electricity. And to date, very few of those works have resulted in SUD schemes. Street works offer huge potential for one strand of activity to retrofit SUDs across the city. This potential is further enhanced by digital technology, where we can get insight on where areas with an opportunity need for SUDs overlap with potential future street works. So effectively, the model we're exploring is this. The water utility or the city identifies priority areas for SUDs interventions based on their modelling and regulatory targets. When street works are undertaken, the proposed working area is mapped against these priority areas. Where there is alignment, then a market mechanism occurs, with payment to the contractor to also deliver SUDs. Lots still to be worked through in terms of how it will work, calculations of market value, but a huge opportunity to deliver SUDs efficiently at scale and optimise processes. been around technical and financial issues, which is all very important. But I also think it's important that we remember that blue-green schemes all sit within communities. And we are continually exploring tools and processes to best engage local communities in solving wider flooding issues. And we currently have one live research project in the UK working with a number of water utilities there. SUDS Plus is an innovative government-funded project. It is aiming to establish a community-based approach for designing, delivering and monitoring SUDs that provide multiple benefits to the community and the environment. The project is aiming to focus on how water can be shifted from a problem to an asset. And it is aiming to redress the traditional approaches where residents are consulted very late and to work with them from the start to co-create interventions. One of the key challenges we need to address is language and communication, ensuring that complex principles are presented simply and are understood. As research develops, we are developing a number of outputs that may be of interest, including engagement and workshop tools, survey proformas, and reports and visuals. Please feel free to explore them. But I do think it's important that in amongst all the clever technical innovations that you may be exploring over the next few days, we continue to look at also innovate in how we engage and work with local communities too. Finally, I thought it'd be useful to briefly touch on the subject of stormwater reuse. I think if it isn't already, in large parts of the world, this will be as important an area of focus as flood risk, water quality and nature-based solutions, as we look to adapt to a changing climate. We've done some work in Australia in this space, including mining of sewers for water. And I would just like to share some initial insights from there with you today. Melbourne is very much recognised as a vanguard city when it comes to urban water management. It has been through a number of stages of water management and interestingly has been focused on stormwater reuse for almost 20 years or more, whilst now also beginning to look at nature-based approaches to rebalance runoff. In exploring stormwater reuse, there was a recognition a few years ago that a new approach was needed. New collaborative governance structures were created to integrate the management of the water cycle. There's also a need to recognise and re-evaluate the opportunity and benefits associated with stormwater reuse, and a need, as with other examples, to explore more collaborative delivery models. As a city, whilst conventional water supplies are in decline, stormwater and wastewater resources are growing as the city grows. To address the supply-demand gap, Melbourne's water strategy is targeting 150 gigalitres of alternative water supply by 2050. And there is a clear focus already within the city on how stormwater reuse can support the city's livability aspirations. Increasingly, though, the opportunity to look at stormwater as an alternative water supply. At a local scale, they are showcasing a development delivered by a water authority in partnership with a developer, 500 homes with both recycled wastewater supply and rainwater harvesting tanks. Rainwater is used in the hot water supply system. Smart technology is also used to monitor rainwater tanks and preemptively empty them before a storm to capture rain to minimise peak stormwater flows. And I know there are a number of similar systems in the market at the moment, but this one's really interesting both in terms of a water supply and an attenuation, dual function. But more interesting for me probably is starting to explore regional opportunities for stormwater. New development areas in Melbourne already deliver stormwater treatment wetlands as standard practice as part of planning. And the opportunity now is to create linked harvesting networks to capture the treated stormwater from these wetlands and transfer to local reservoirs. Treated stormwater can then be utilised for agriculture, environmental needs, or city water supplies in the future. So, three quick points to close. And apologies for repeating myself. Clearly there are challenges, but there is a huge opportunity for us to reframe water in our cities and to deliver a citywide infrastructure that is protective, climate ready and community driven. And I think the onus is on each of us to grasp that opportunity, recognising that we need to do things differently. In terms of doing things differently, we need to take a systems-wide approach, working across systems that don't just involve water specialists. And I think we need to move from discrete interventions into a wider system and spatial framework that can set the vision for what we want to do. That's what we set out to do in Shanghai. And delivering that vision will be facilitated by a range of systems and processes. And finally, we need to ensure that we get better understanding and capturing of value to enable us to deliver wider and more robust business cases that support new next-generation approaches. These are exciting times for water and environment professionals. The challenges of water and climate change are real and daunting, but the opportunity is there to shape a better world. Thank you.
Thank you very much. Justin, can I just ask you one very quick question out of these places that you've mentioned, New York, London, and others? In your judgment, which town, which place would be a sort of a benchmark, a blueprint, a role model in terms of green and blue infrastructure?
I always refer our clients to New York.
New York.
I say New York. It's a massive city, and in many respects, trying to make a comparison with a town might be difficult. But if New York can do it with complex city infrastructure in place, whether that's subway systems or whatever, and they can install...
Then anyone can do it.
Retrofitting is a challenge, but if New York can retrofit, I think anyone can retrofit with the will.
Of course. I was just wondering, because you're talking about next generation infrastructure,
Yep.
and with the time that's flowing so fast and the technology is changing so fast, then, you know, we're preparing for what is next generation? We're preparing for next generation, but once we prepare for this next generation, the generation after will be in place already. So how do you define this next?
Well, next generation infrastructure, I've taken from the World Bank report on blue, green, grey, and they refer to that as a integrated blue, green, grey system.
Right.
But I also think in our design with water approach, we talk about systems being smart, systems being resilient, systems being adaptive, you know, because the future is uncertain.
Open to change.
Yeah, but
it's imminent.
Yeah, but the more we can integrate nature into our systems, the more inherent adaptation capacity there is.
Thank you very much, ladies and gentlemen. Justin Abbott. Brawa wielkie, dzięki.